Hello! In this video, we are going to explore, I almost said explode, oh, I'm not doing that, explore systems of equations, and specifically we are going to use the graphing technique in this video. So to begin with, what is a system of equations? Two or more equations using the same variable, two or more. We can have 3 equations, 4 equations, 5 equations. It could get a little lengthy. But 2 or more equations using the same variable. So here is an example. Both equations have x and y, and there are 2 equations. If there are 3 equations, then they would also have a z. If there are 4 equations, we'd probably have a w. All those fun letters. Okay, so a solution to a system of equation is an ordered pair because you have an x and a y that makes both equations true. It has to work in both, guys. If it only works in one, it's not true. Okay, it's not the solution. It has to make both true. That is so important. All right, graphing systems. So, not anything super tough because you already know how to graph linear functions. But there are 3 types of solutions. First, we see that there are 2 lines on this graph, one for each equation. Now, we find the solution. Whenever our graph looks like this, we find our solution at the intersection. This intersection is negative 2, 1. Therefore, that is our solution. That's one possibility. Now, what happens if you graph 2 lines and they're parallel? Okay, here we don't see an intersection, do we? No. So guess what? The solution is no solution. There is no solution. All right, and then our last option, I only see 1 line. Ms. Jordan, you messed up. No, there are 2 lines graphed directly on top of one another, meaning their equation was the exact same, meaning that they touch at every single point of the line, and we understand that there are an infinite number of points on a line. Therefore, we have infinite solutions. 3 types of solution. You have a 1 solution, which is written as an ordered pair, negative 2, 1, no solution, and then which is parallel lines, and infinite solution, whenever your solutions, plural, whenever your lines are the exact same. Graphing systems. To do this, we're going to graph both equations. You know, to graph an equation, you must have the equation in slope-intercept form before you can graph. You're going to determine the solution. Determine either where the intersection is at, if there is an intersection, there's not an intersection, are they parallel or are they the same line? Then you need to check the solution. This is more comes into play whenever we solve algebraically, but if you want to make really good grades, which is at some of your goals, which I love, or if you just want to make sure that you're accurate, then just plug it into both equations and make sure that it makes the equation true. So we're going to solve the system of equations by graphing. So we have the system of equations 4x plus 2y equals 8 and x minus y equals 2. So the first thing we need to do is get both equations in the slope-intercept form. Remember, that is y equals mx plus b. 4x plus 2y equals 8. Let's subtract 4x from both sides because we need to isolate our y. 2y equals negative 4x plus 8. My y is still not isolated, so I'm going to divide everything by 2. Y equals negative 2x plus 4. Now, that equation is in slope-intercept form. But we're not finished yet because we have this second equation. We need to subtract x from both sides. And we get negative y equals negative x plus 2. But we don't want a negative y. We want a plain Jane regular y. So we're going to divide everything by negative 1. So y equals a positive x minus 2. Now it is time to graph. Well, to graph, we need to know our slope and our y-intercept. For the first equation, our slope is negative 2, 4. There's our y-intercept on the graph at positive 4. Okay, from here, our slope is negative 2. So we're going to go down 2 to the right 1. Down 2 to the right 1, and we're going to connect with a nice, beautiful line. Now, for our second equation, our slope is 1, and our y-intercept is negative 2. So our y-intercept is now graphed at negative 2. Our slope is 1, so we're going to go up 1 to the right 1. And once again, we're going to go up 1 to the right 1, drawing a nice, beautiful line. Now we've graphed the lines, we have to look for an intersection. Do we have an intersection? Yes, we do. This point is 2, 0. So that is our solution to this system of equations. If you took 2, 0 and you plugged it back in, 4 times 2 is 8. 2 times 0 is 0. So 8 equals 8. On the bottom, 2 minus 0 equals 2. Does 2 minus 0 equal 2? Yes, it does. So this solution works for both equations. Let's look at a second example. That dot was not supposed to be there. It will. We have 2x plus y equals 3 and negative 4x minus 2y equals 2. Once again, we need to get both equations in slope-intercept form. So starting with the first equation, we need to subtract 2x from both sides, so y equals negative 2x plus 3. And the second equation, we're going to add 4x to both sides, so negative 2y equals 4x plus 2. And then we're going to divide everything by negative 2, so y equals negative 2x minus 1. Time to graph. Our first equation, our slope is negative 2, our y-intercept is 3. Our second equation, our slope is negative 2 and our y-intercept is negative 1. Graphing the first equation, not graphing yet. What do we notice about our slopes? They are the exact same. So what do we think is going to happen with this graph? What do we know about equations that have the same slope? They're parallel, right? Okay, so this graph should be parallel, which tells us that our solution should be no solution. Right, okay, but if you don't believe me, I'm going to show you for sure. So our y-intercept is 3. Our slope is, for equation 1, our slope is negative 2, which is over 1. So down 2 to the right 1. Once again, I'm going to go down 2 to the right 1 and connect that line. For our second equation, our y-intercept is negative 1. We're going to go down 2 to the right 1, down 2 to the right 1. We're going to connect that line. Do these equations intercept? Absolutely not. So our solution is indeed no solution. How about that? So hopefully this video shows you how you can graph two equations like normal, but just graph them on the same line, and then that will help you solve a system of equations. And that concludes this video.